So in this video we will talk about acid-base chemistry. The first question asks you to identify the strongest base. The strongest base is going to be the one which will have the most electron density, and therefore we have to judge it based on which oxygen here has the highest electron density. So they all have 4 carbon chain. The first structure is the butanoic acid anion, and the second one is going to be the butanoic acid. The third one is going to be 3-chloro, and the fourth one is going to be 2,2-dichlorobutanoic acid, acid anion, or as carboxylate. So, and if you look at this, because chlorine is able to withdraw electrons, this one is going to have less electron density compared to this, and since all of them have chlorine, this is going to be the strongest acid. So let's give one for example. And since this one has a chlorine nearby compared to this which has chlorine 1 atom away, this one is going to be the second largest, because the electron withdrawal efficiency dies down as you increase the distance between the electron withdrawing group and the electron source. So that is second most basic. This one is going to be third most basic, and this one is going to be the least basic. Okay, so the order of basicity is 1, 2, 3, and then 4. Therefore option A is the right answer. Okay, so if you look at the next one, which is the order from most acidic to the least acidic. So alkane is generally the only thing that will be the least acidic, and that's the case here also, because you have alkane that is going to be the least acidic. And between these three groups, they all have C11Os, as you can see here. And if you look at this hydrogen here has 2 carbonyls next to it, and therefore the structure is going to look like that: oxygen, carbonyl CH2, carbonyl oxygen. So this hydrogen, there are 2 hydrogens. If you deprotonate one of them, since there are 2 conjugation groups that you can have, this electron is going to be very dispersed, making this base a lot more stable, and that makes the corresponding conjugate acid a stronger acid. And since there are 2 carbonyls, this is going to be the strongest acid. So strongest acid, weakest acid. Okay, now between these two we have to see how the anions look. So that is the anion for structure 3, the conjugate base for structure 3, and the structure 4 is going to look like that. It's also something that has a carbonyl, except you have an oxygen on the other side and a CH2CH3. So here these electrons are going to go in. That's the only thing that will happen. Whereas in this, if you generate the anion on this side, these electrons move in, it moves out, just as in the case of acetone anion. But also this oxygen also donates electrons, and you can have the same conjugation. And since this oxygen donates electron to the carbonyl's need, or the ability to pull electrons from this carbon, is going to be diminished, because there is an electron source here that moves in as well. And therefore between these two, this is more stable anion. That means the corresponding conjugate acid is going to be the stronger acid for structure 3 compared to structure 4. Okay, so 2 is the strongest acid, 3 is the next stronger acid, 4 is the next stronger acid, and 1 is the weakest acid. So we are looking at 2 followed by 3 followed by 4 followed by 1. So 2, 3, 4, 1, that's going to be option C. So in question 4, which is the order from the strongest acid to the weakest acid in the following species? Again, another ordering problem. So here we have 2 cations and 2 neutral species. So cationic species are going to be generally stronger acids, as long as the acid there is a hydrogen, that the hydrogen containing atom has the positive charge, right? So between 2 and 4, because oxygen is more electronegative, this one is going to be the strongest acid. So 2 is the strongest acid, 2 is the strongest acid, followed by 4. And again between methanol and amine, because oxygen is more electronegative, 1 is going to be the next stronger acid, followed by 3. So 2, 4, 1, 3. That's option A. Alright, so the imidazole ring system contains 2 nitrogen atoms, is found in the amino acid histidine. Which statement is true regarding the basicity of the 2 ring nitrogen atoms? Okay, so we had to look at the basicity of these 2 and we had to comment on, and we had to see which one of these statements are true. Okay, so one thing we have to understand is this 5-membered ring has 2 nitrogens, so that's nitrogen 1 carbon away you have nitrogen 2. That's a lone pair here, there's a lone pair on this. The third bond is a hydrogen, and you have a double bond between these 2 and over there. Now what you should recognize is this lone pair is not going to be able to conjugate. Okay, as we have seen before, this lone pair is not going to be able to conjugate. It won't conjugate on this side or either side because this is a pure P, or sorry, this is an sp2 hybridized orbital. It won't be able to mix with the pure P that you see, which is perpendicular to that lone pair. Okay, therefore those 2 won't be able to mix to be able to conjugate. Whereas this nitrogen, it is going to be able to conjugate because it is sp3 hybridized. Okay, it's sp3 hybridized. We have seen this before, so this conjugation happens. Okay, and so on and so forth, and therefore these electrons are conjugated, these electrons are not. That's what you should understand. So based on that, let's see which of these statements is true. So both are strongly basic since the ring is aromatic. That's not true. The nitrogen atom labeled 1 is more basic than 2. Nitrogen atom labeled 1 is more basic than 2. That is true. The nitrogen atom labeled 2 is more basic than 1. That is not true because these electrons are conjugated. They will be less available, making it less basic. Neither of the nitrogen atoms would be considered basic, and that's not true either. So option B is the right answer. Which of the indicated protons in this compound would have the smallest pKa value? So smallest pKa means highest acidity. Okay, alright, so if you look at all these atoms, this is connected to a carbon, connected to a carbon, connected to a carbon, connected to a carbon. They're all carbon connected. The only difference is some of them are conjugated, some of them are not conjugated, right? So for example, this hydrogen, if you make a lone pair from the loss of that hydrogen, okay, whatever that is, these electrons, they are not conjugated. Okay, that cannot be conjugated because we have seen when you pull this in, you're going to have a structure that's going to have that double bond next to each other. That's not allowed in a aromatic ring, so therefore that electron is not conjugated. In fact, this is going to be the weakest acid. Okay, so that's that. Now between the 3 positions B, C and D, sp3 hybridized carbon, sp2 hybridized carbon, sp hybridized carbon, and simply because this is sp hybridized and conjugated, this is going to be the strongest acid. Okay, this is going to be the strongest acid. So